In this week's lab, we will synthesize N-acetylanthranilic acid from anthranilic acid, acetic anhydride, and water. Once synthesized, we will observe the triboluminescent properties of N-acetylanthranilic acid. Triboluminescence is the emission of light from a material upon stretching, compressing, or fracturing of the material. Triboluminescence was first reported by Sir Francis Bacon in his 1605 Advancement of Learning, where he was discussing the fracturing of sugar crystals. Weidmann is credited for creating the term triboluminescence in 1895, which comes from the Greek word tribun, which means to rub, and the Latin word lumen, which means light. Two examples of triboluminescence are shown here, being nicotine L-salicylate and quartz. It is estimated that 36% of inorganics, 19% of non-aromatic organics, and 37% of aromatic organics exhibit triboluminescence. Some examples are cis-4-octene, L-ascorbic acid, phenanthrene, coumarin, and the compound we will be synthesizing today, N-acetylanthranilic acid. Triboluminescence is the result of fracturing of some asymmetric materials. The stress applied separates charges. These charges can recombine and ionize nitrogen in the air, and this results in a flash of light. However, this phenomena is not completely understood. Shown on the right are two examples of triboluminescence, being tape and wintergreen lifesavers. Wintergreen lifesavers exhibit bright triboluminescence. This is because they contain sucrose and methyl salicylate, which is for flavoring. The grinding of sucrose results in triboluminescence of UV light, as shown in the top spectrum. In the middle is the excitation and emission spectra of methyl salicylate. So the light emitted from the sucrose excites the methyl salicylate. Once excited, the methyl salicylate can relax back to the ground state by emitting a photon of lower energy. This results in the lifesaver triboluminescence spectrum shown on the bottom, in which visible light is emitted, giving the blue color that is shown on the bottom right here. Current research is taking advantage of triboluminescence for various applications, including triboluminescent fabrics, which are shown here, and were made from zinc sulfide-based materials. These fabrics could be used for lightweight, flexible, and wearable displays. Another application includes flexible handwriting devices, as shown here, which could be used for recording electronic signatures, as they could record things like local pressure and speed of writing, which is useful information for identification verification. Other applications include stress sensing, damage sensing, and structural health monitoring, in which the detected mechanical stress is converted into visible light. In this week's lab, we are synthesizing N-acetylanthranilic acid, which again is a triboluminescent material. The first synthetic step involves heating a mixture of anthranilic acid and acetic anhydride at reflux for 15 minutes, which yields 2-methylbenzoxazanone and acetic acid. For the second step, we are heating this compound at reflux in the presence of water, causing a hydrolysis reaction, which hydrolysis is defined as the breakdown of a compound by water. This then yields our final product, N-acetylanthranilic acid. Shown here is a summarized procedure. We will first add 5 grams of anthranilic acid to a 100 milliliter round bottom flask along with a boiling stone. Then attach a reflux condenser and add acetic anhydride. Heat the mixture under reflux for 15 minutes, then allow the solution to cool and add 5 milliliters of water. Boil a second time and then let the mixture cool slowly again. Vacuum filter the crystals and wash them with cold methanol. Grind the crystals into a powder and add to hexanes. Then vacuum filter the crystals a second time. Place the crystals on a watch glass and dry them in the oven for 10 minutes. Then crush the crystals between 2 watch glasses in the dark to observe their triboluminescence. And some safety considerations. This week we will be working with acetic anhydride, which is corrosive and can cause skin burns, so please always wear your gloves and goggles while in the laboratory. Beyond this, we will be generating waste. Things that will go into the organic liquid waste jug are things like acetone, methanol, hexanes, and acetic anhydride. Things that will go in the solid waste bucket are things like boiling stones, our product and acetylanthanoic acid, and any contaminated gloves or paper towels.